Hello, my name is Alexandra Savchuk, and my AES Student Design Competition submission is low-frequency anti-vibration platform for lightweight turntables. With the rise of digital streaming platforms, traditional audio formats like CDs and vinyl records have seen a drop in popularity. Despite this trend, vinyl has experienced a strong comeback in recent years, with more and more albums being released in analog format. As a result, the market has shifted towards making turntables that are more affordable and widely available. However, this often involves using cheaper materials and simpler designs, which can lead to mechanical instability and unwanted vibrations appearing during playback. Vibrations can originate from both internal mechanisms, such as motor and platter operation, and external sources, including nearby traffic or furniture movement, which all result in playback disturbances. As shown in the figure on the left, the critical range of externally induced vibrations begins at 5 Hz and extends to 20 Hz, where horizontal vibrations from the floor and vibrations from furniture overlap. Prior studies have also identified that resonance of the tone arm cartridge assembly appears around 8 to 15 Hz. This also highlights that low-frequency disturbances are especially problematic. Since vibration isolation is effective above the resonant frequency of the system, traditional methods rely on increasing mass to shift this frequency. However, such an approach is impractical for lightweight devices like turntables weighing less than 10 kilograms. Because of that, the most effective and universal strategy is to isolate the entire turntable from its supporting surface, using, for example, an anti-vibration platform. I decided to test several different vibration-isolating materials, such as elastomers, springs, round and line rope isolators, and compare them to the original turntable feet, as well as to regular wooden blocks, which served as a reference for a rigid mounting. To generate vibrations, I used a tapping machine, and I measured the vibrations with accelerometers. These were placed, for example, on the cartridge, the platter, and the ground. To analyze the results, I used spectral analysis and transfer functions. Transfer function showed the ratio of the vibrations when the turntable was placed on isolation materials versus on the blocks, or ratio of vibrations registered on the cartridge to those on the ground. The spectral analysis on the cartridge showed that when the turntable was placed on elastomers, springs, or round rope isolators, the vibration amplitudes were lower than when it was standing on wooden blocks. The opposite happened with line rope isolator and the original feet. In those cases, the vibrations on the cartridge increased across the whole frequency range. The transfer function confirms these results. A negative value means the vibration when the turntable was placed on isolators were lower than when it was standing on the reference blocks. Again, it was clear that the original feet had poor vibration isolating properties, as well as line rope isolator. When comparing vibrations on the cartridge versus on the ground, it was hard to achieve negative values at the very lowest frequencies, but this shows that the cartridge is quite sensitive to the external vibrations. The lowest values across the full frequency range were achieved with the round rope isolator, as it was effective already above 21 Hz. Based on this analysis, I created a prototype of the vibration isolation platform. It's mostly made of plywood. At the bottom, it has rubber feet. Then there are 2 plywood plates with round rope isolators placed in between, because they provided promising vibration reduction. There's also space to add extra weighting plates, which can be used to adjust the mass of the platform and further tune its vibration isolation characteristics. The turntable can be placed on top of this platform. You can see it stays stable even when the platform moves around. Thank you for listening to my presentation. If you have any questions, feel free to contact me. Have a good day!